Number 17 was specifically designed to make sure that you understand the difference between three types of inverses. And it's directly related to inverse functions, and so it's a conceptual question relating to understanding derivatives, in specific arctan, and also notation. So let's take a step back. There's actually three types of inverses that you've learned about. There's the additive inverse. So what is the additive inverse of x? Well, that's the negative x. Why? Because when you add x plus negative x, you end up with 0, which is the additive identity. Additive identity. That's what we mean when we say the additive inverse, because we want to say what can I add to this in order to get the additive identity. The next question is, what is the multiplicative inverse of x? This is denoted as x inverse, like that. I'm going to make all this a little bit bigger for you here. Oops. There. So notice that that's it, but it's somewhat of a misnomer. So in general, what we're asking is, we are saying it is 1 over x. And the reason is because x times 1 over x, sorry, that's a plus, x times 1 over x is equal to 1, which is the multiplicative identity. So in this case, we use x to the negative 1 to indicate that for a single number, x, then the multiplicative identity is negative 1. But when we're talking about function inverses are defined as the function such that f of f inverse. So in other words, if you take the inverse of the function and compose it with the function, you're going to get back the original argument. So that's a definition for a function inverse. And by the same token, f inverse composed with f will also give you x. So going back to this particular question, y equals tan inverse of x is saying y is the angle whose tangent is x. And we did this in class a number of times, right? We said that y here is the angle and the tangent is x, meaning that the tangent is x here over 1, opposite over adjacent. And that is because if you did the tangent of the arctangent of x, you would simply get x. So this is answer D, the angle whose tangent is x. Question number 18 falls right along with number 17. If f and g are inverse functions, then if we compose f of g of x or g of f of x, we should get x. So that answer is true. In other words, what they're saying is if they're inverse functions, then f is equal to g inverse, or g is equal to f inverse. In either case, when you compose them, you will get the original argument.